In section 8.2, we'll talk about two-dimensional figures. So with a curve, we have a simple curve, which is something that looks like this. So you trace, but you do not touch more than once. So it does not touch more than once. So what does a closed curve look like? Well, it does touch more than once. The start and the ending point are the same. So an example of that, starting point, ending point are the same. So that would be a closed curve. And then we have a thing called a simple closed curve. So what happens was the start and the end points are the same. But what happens now is it does not touch a point more than once. So it does not touch a point more than once. So how does this look different than the V8? Starting and ending are the same, but in no other case does it touch the curve more than once. Polygon. A polygon is just a simple closed curve, so that's what it's going to start with. However, the curve is made up of line segments. So what we're going to do is we're going to catch line segments and never touch more than one. So that would be a polygon. The vertex is a point at which two sides meet. So the point at which two sides meet, or two line segments. So on this diagram right here, that would be considered a vertex because you have two line segments meeting there. The sides are the line segments. The sides are the line segments. So on this diagram, these two line segments are meeting at that vertex. Congruence is used with shapes. This idea of congruence is used with shapes, and it looks like this. It's an equal sign with the squiggly on top. Okay, it's not an equal sign. It's not just an equal sign. There's more to it. What this says is that corresponding angles have the same measure. So corresponding angles have the same measure. And corresponding sides have the same length. So there's two parts. One deals with angles and one's dealing with sides. And in both cases, they're going to be the same. And we measure sides with the length and the angle with a. We'll talk more about this idea of the congruence later on when we deal with shapes.